Okay, hello everyone and welcome to the first session of Warwick Data Science Society's Beginners R course. I'm Tim and I'm the current president of Warwick Data Science Society and the author of this course. And I'm also going to be teaching the course, at least for this iteration. That said though, there are a lot of people behind the making and logistics of this course, so I'd like to give a big thank you to them. There's our mentors who are helping to support people in their learning and our education officer who's helping to coordinate the course. So there are two ways that you can follow along with this course. The first is kind of independent learning. All of the videos for this course are going to be going up on our YouTube and the resources will be linked in the description. You're free to learn by yourself whenever you want. But the other method, and the one we think is better, is actually get involved through the society. So every term we're going to be running an iteration of this course. You can get involved and have mentorship and guidance on following through with this course and learning more. And we'll also be offering certification for people that complete the course with all of the homeworks. So we would advise doing that. If it's currently at the start of a term, you might be able to hop on with a current iteration. If it's coming to the end of a term, we'll just keep an eye on our socials and maybe next term you can get involved. So I'm not going to go through any of the details of the course. If you look at the link in the description, that's where you can find most of the information. Or if you're doing this course internally, then a lot of the information is in the Microsoft Teams team that you'll have been invited to. So instead, we'll kick off with the content of today's session, which is all about the basics of using R, especially for creating visualizations and plots. All right, let's get started then. So it's worth first mentioning that all of the resources for this course, so the presentations, the homework and solutions, and any datasets we use, are available and open sourced on our GitHub, so on the Society's GitHub. And you can find them all at this link here, the top one. But an easy way to access these resources is through the course website. And that's found at the second link here. And that will be put in the description or linked in the Microsoft team that we're using if you're taking this course internally to the Society. We'll start with some introductions, a bit about the course and why it's something that you should be wanting to take part in. I'm going to start with prerequisites, of which really there aren't any. If you have a good understanding of numeracy and can get your way around a computer, then that's great. That'll put you in a good position to get started. And if you have any previous programming experience, that's great. Should make it easier to learn. But we're going to go right from the start anyway. So no past experience is required or even expected. So what is this course all about? Well, it's based on a book called R for Data Science by Hadley Wickham and Garrett Grolland. So Hadley and Garrett are really big names in the R world, and this book is absolutely phenomenal. It's a really detailed guide of how to do data science using R, it's unsurprisingly. But the problem with this book is that it's really big. It's about 500 pages, and it's quite dense. And so what we wanted to do was to take this course and condense it down into the key ideas, most important notions, and really focus on the actual practical aspects of learning R. So if you want to learn kind of even more than this course covers and kind of go into the details, you can access this book for free at this link here. But we're going to try and take the most important bits to kind of get you started as fast as possible. And so this course differs from the book in two key ways. The first is a focus on immediate gains rather than trying to master the whole of this thing called the Tidyverse, which we'll talk about more in a moment. And also the exercises tend to have more of a practical focus rather than just kind of esoteric questions about the philosophy and nature of R. So what will we cover in this course? Well, it's going to be using these things called R, RStudio and the Tidyverse. We'll show you how to set those up, how to use those, and actually what on earth they are. And then we'll use those tools to input data. So we can take that from the web, we can then clean it up. We could wrangle it, so take it from one form into another. We could transform it, manipulate it to try to answer questions about that data. And then finally, visualize that using plots and graphics. And also we're going to look at how we can effectively communicate with our data to try and make sure we're honest and efficient in the way we communicate. And so what won't we cover? Well, it's unsurprising if we're taking a book of 500 pages and condensing it down into just 5 sessions, we're going to miss out on a few things. So we're not going to have a look at kind of complicated data types. So dealing with dates or times. We're going to stick mainly with numeric and categorical data. And so we're also not going to handle any non-categorical text data. So general text processing and natural language processing, we're not going to get into that. Iterative techniques, so if you know other languages like Python and Java, you might be familiar with the notion of a loop or a map. We're not going to get into those in R. It turns out you can get quite far in R without needing to know those. We're not going to get into statistical modeling, just because we don't want to have any kind of prerequisites of maths and stats. And we're also not going to talk about communicating to wider audiences. So the final kind of endpoint of our analyses will be maybe exporting a data set to a text file or creating an image, a visualization. We're not going to look into, say, making PDF documents or presentations using our data. But if you want to learn more about any of these things, you have a look in R for Data Science. It's all covered in there. And so the teaching style for this course is going to be deliberately fast. And so if at any point you're feeling like things are going past very quickly, it's hard to take it all in, don't worry, that's the point. And the reason for this is that I've taught this course several times in several different formats, and I found that no matter how slow we went, it's still really hard to take new stuff in for the first time. And so I decided it was better to go through really quickly and then give people more time to work through things by themselves. So rather than considering this session as a chance to learn everything, think of it as a time to build up a mental map of where you can find resources and kind of build a list of the things that R can do, and you can find how to do them later. And so essentially we're going to just run through all the ideas, and then we're going to have homework sessions, or not homework sessions, but homework sheets. You can practice and apply these ideas, and that's when the learning should happen. And a lot of research shows that people learn much better by doing than by listening and watching. So that's kind of the philosophy of this course. So just don't be put off. It feels fast. You're meant to learn during the homework. That's the idea. So I want to start by offering some motivation as to why this course is even important and why we should learn this thing called the Tidyverse. And we'll explain more about what the Tidyverse is later. But for now, let's start with why we should learn data analytics or data science at all. And if you're a follower of the Data Science Society, perhaps this isn't any new news to you, but data skills are in massively high demand. So in all sorts of careers, really whatever you're doing, there's going to be data involved because the modern economy is driven by data. And so knowing how to process that data, how to answer your questions based off it, is really important and can let you really thrive in your career. But there are many different tools you can use to process data. So why use R and specifically this thing called the Tidyverse? And so one reason is that it's a lot more powerful than tools like Excel and Tableau. So these are kind of graphical tools that are very easy to get you started, but are very limited in their scope and are not going to let you answer more interesting and complicated questions. So R is also an open source and free language. That means anyone can use it, anyone can contribute to it without having to pay any licensing fees. And so the beauty of this is that, anyone can use it, anyone can have access, unlike with things like SAS and SPSS, where you need to pay to use it, and that can limit who has access and where you can share your material. Using R makes whatever analysis you produce accessible to everyone. There's also a really large and friendly community for R, so especially on Twitter, there is a great community for learning R and getting support with that. So it's a great place to be learning. And R is also a very intuitive language. So unlike some more conventional programming languages like Python, Julia, or JavaScript, R feels a lot more intuitive, like you're speaking to the computer rather than having to translate your thoughts into some sort of machine code. And so you can get started with R quite easily, especially if you've never learned to program before. And so how is this course going to be ran? Well, there's going to be 5 sessions running weekly. At the end of that, if you're taking part in the course internally with the society, we'll be running a data visualization competition so you can apply your skills on your own data set, and we'll see who can come up with the best visualizations. But we'll have more details on that in the 5th week. So each session is going to introduce new material and kind of work through some examples. The idea is just to sit back, try and follow along. You don't need to be running these examples for yourself. You can if you want, but really the homework sheet, that's the time for you to practice actually applying this material and actually taking it in. Okay, so we mentioned this thing called the Tidyverse. What on earth is that? It's the name of this course. Let's kind of tackle what that is. But to do that, we're going to start with some foundations. What is R and what is RStudio? Okay, so we'll start with R. So R is a statistical programming language. It's used for kind of statistical computing and for graphics and visualization. And so it's built on a very historic language called S, which was developed in the mid-70s. And so R is known for being highly extensible. So people can add features to the language to make it more powerful than it was originally intended. And as mentioned before, it's completely free and open source. So anyone can use it freely and can contribute to it, adding new features. And it's also got a very large and beginner-friendly community. And so R is an incredibly powerful tool. It's not only used for, yes, it was originally intended for statistical computing and graphics, but since then it's expanded to cover things like machine learning, statistical modeling, big data, and many other things. But, I mean, in fact, it's even used for websites, for notebooks, and presentations. So this presentation here that we're looking at was made using R. There really is kind of no limit to what you can do with it. And so here are the instructions for setting up R. You can follow along with these if you're watching on YouTube, or if you're taking part in the course internally. We have instructions in Teams which are a bit more detailed. You can also ask your mentor if you need any support with this. Okay, so that will get us set up with R, but there are limitations of using R in its current state. And so the problem is that the built-in code editor for R is quite old, quite ugly, and missing a lot of features. I guess I can show you what that looks like here. If I open R, you get something like this. And so this is just kind of like a text editor. It might look a bit different on your computer because I'm running Linux here. But it's not a very friendly way to be writing things. There's no buttons, no graphics. It's very simple. We literally just type our text straight in here and run it. So it's not a really nice way to be coding. But there's a better alternative, and that's this thing called RStudio. So RStudio is a program that sits on top of R that allows you to do R coding in a much more simple and graphical way. And so RStudio is a integrated development environment, or an IDE, and it's made specifically for programming in R. So it contains many features that allow you to code R in a much more simple way. So it can display your code and output in a much cleaner fashion. It can give you kind of access to help files, your code history. It can track your environment. We'll explain what that means later. And essentially, it just makes coding in R much easier. So if you're going to be coding in R, you probably want to be using RStudio. And so to set up RStudio, you can follow these instructions here, or again, more details will be given in the Microsoft Teams team for this course. Okay, so getting around RStudio, actually, yeah, let's open it up. So I have RStudio open here, and when you first open it up, it will look something like this. So probably things will be in slightly different positions. That's okay. I've moved them around just to make it a bit easier to use for this course, but it should look generally something like this. So you probably have 3 panes open, maybe 4, and there's these different tabs at the top of these that you can jump between. That's what RStudio looks like. And the most important part that we're going to be using for now is the console. So if I go back down to here, we'll see there's one section titled console. Let's say if you're on terminal, you could click over onto console to get that. And that's the place we're going to be writing our code. So how do we write and run code in R? And so it's quite simple. We simply type it into the console and then press the enter key, and that's going to run it. So for example, we could use R as a sort of basic calculator. So we could add together numbers, times, divide. So yeah, let's have a go at doing that. If I go over to the console here, and make my text one size bigger, just so we can see clearly, I can type in 1 plus 2, and then press enter. and that's going to give me the response here. And what this is saying is there is one output, and that is the number 3. And so I could do other things here. I could do maybe 5 subtract and 1. That's going to give me 4. It's worth mentioning at this point that R is very lenient when it comes to white space. So I can add and remove spaces, and R will understand my code exactly the same. If I get rid of the space there and put a load of spaces here, maybe some spaces at the start, at the end as well, R doesn't care at all. It will read it exactly the same. So we put spaces in, there's conventions for where to put spaces, just to make it easier for humans to read, but the machine, R, doesn't care as much. And so for doing a bit more maths, we can use plus minus, an asterisk for times, a slash for divide, and this caret symbol, which is shift 6 on a UK or US keyboard, for exponentiation, so to the power of. So we're just going to pause for a second. If you're watching the video on YouTube, you can pause for yourself, or if you're watching one of our hybrid live sessions, then the video will be paused for you. We'll just have a moment to have a go at these and just check that everything's working okay for you. So we'll join back in a second. Okay, so hopefully that code is working correctly for you, and that's your first taste of what R coding is like. We're now going to ask, what is this thing called the tidyverse? So the key kind of idea of R is that it's a very extendable language. You have this kind of base version of it, but then because it's a free and open source language, people are welcome to add their own extensions to it to make it even more powerful and do more complicated things. And so this additional capability comes in the form of these things called packages. And they can be written by any user just to let R do more powerful things. And so a package is a collection of functions, that's things that do stuff, of data and documentation, so explaining how things work and how to use them. And the idea is these extend the usual capabilities of what R can do. And so the tidyverse is kind of a meta package, a collection of packages for performing clean and efficient data analysis and data science. And so each of the packages inside of the tidyverse, so the tidyverse is a collection of packages. Each of those is designed for a specific purpose in the data analytics or data science pipeline. So for example, there is a package for importing data, one for visualizing data, one for manipulating data, and there's many different packages in the tidyverse. The key idea is that they share a common philosophy of data, and so they gel really well together. You can work seamlessly between them. It's almost as if you're in the same package. Well, I guess you are in the same meta package. And this is different to languages like Python, in which the data science ecosystem is quite fragmented and doesn't perfectly fit together. With R and with the tidyverse, things are made from the ground up to just work perfectly together, and so it's really natural to code with the tidyverse. And so to use the tidyverse, we'll have to do 2 things. The first is to install it. So as mentioned, this is an extension to the language R and does not come built in. And so to install it, inside of the RStudio console, we can run the command, the function. I'll explain more what a function is later in today's session, install.packages. And inside of that, inside of quotes, so some brackets and then quotes, we have the package we want to install, so tidyverse. If I take this and put that into my console, I can run that and that will install it. Oh, it is installing it. I thought I had it installed already. But yeah, so that's installed it. And so you only need to do this one time per computer. That's just bringing in the files from some remote server and installing them on your computer. If you run it a second time, it's not going to be a problem. It'll just say, hey, this is installed already. And so now we have to actually load the tidyverse up. So think of this as installing a piece of software. We now have to click on its icon on the desktop and actually open it up. And to do that, we use a command called library. So load this library. And as before, we have brackets, and then we follow that by, in quotes, the name of the package we want to load. So library and tidyverse. So if I do library, and then in quotes, tidyverse, that's going to load up the tidyverse. It's listing here all of the packages inside of the tidyverse that have been loaded by doing that. And so this command we have to rerun every time we open RStudio. So if we close it, we have to rerun this command to get all the features of the Tidyverse available. And so yeah, the analogy is install packages is like installing a piece of software, and library is like clicking on its icon to open it up. It's worth mentioning, because I'm going to subconsciously do this, when we're using library, we actually don't need the quotes. R is smart enough to realize that we're talking about a package name here, and so we can get away without the quotes. But for install.packages, you do need the quotes. I'm just giving you a warning here, because I'll probably forget to use the quotes in the future. Okay, so let's get started with the main body of today's session, and that is data visualization. So whenever we get onto a new topic, I'm going to come back to this map here. And this is kind of a very general map of what the data analysis or data science pipeline looks like. I think it's very useful for kind of putting the new things we're learning into context. And so in this map here, we have many different parts of the workflow. We import our data, tidy it up, and then there's this cycle of transforming, visualizing, and modeling our data. So, and then finally, we communicate that data to a wider audience. I put modeling and communication in brackets here because we're not going to cover it in this course. You can learn more about it in R for Data Science. And so we're going to be starting by learning about visualization. And this might seem a bit strange because it's not at the start of the data science pipeline. But the reason we're doing this is that the payoff for learning visualization is a lot clearer than for importing data. By the end of today's session, we'll have some pretty graphics that you can go share with people and show off what you've learned. Whereas with importing data, we'd import it and then not know what to do with it. So that's quite boring. And so next session, we'll come back to how we can import our own data. But for now, we're going to use data that's pre-packaged with the Tidyverse to give us a head start on visualizing said data. Okay, and so to do visualization, we're going to use a package called ggplot2. And so this is just one of the many packages that are included inside of the Tidyverse. And so it allows us to create very stylish and publication-ready graphics with very minimal effort and in a very coherent and consistent way. And so the GG in ggplot stands for Grammar of Graphics. This is based on a research paper from a few decades ago. It's basically an essay on a certain philosophy of generating graphics that's based on layering. We can start with a base layer, then we add kind of maybe some points, some lines, we add a coordinate system and carry on like that. And we'll find it's a very flexible and really quite intuitive way of creating plots. Okay, so let's start with some baby steps. Let's create our first ggplot. And so to do that, we're going to need a data set. And we're going to use one of the ones built into the Tidyverse. And this is called MPG, which stands for miles per gallon. And so let's first have a look at what this data set looks like. And we can do that just by typing its name into the console and pressing enter. So if I have my console here, I use Control-L to clear it. And I can type in MPG and press enter here. And importantly, this is only going to work if I've used library Tidyverse. If I haven't done that, then this will not be available yet. And so I print this out and I see I have a data set of 234 rows and 11 columns. And it's got columns such as, so each row represents a car, and the columns are the manufacturer, the model of the car, Dispel is the engine size, the year it was made, and various other features there. So we're going to want to visualize this data set. And so this is data on 38 models of car, and it's data from the Environmental Protection Agency in the United States. And there's two variables of interest we're going to look at. So Dispel is the car's engine size. I forget why it's called that, but just keep that in mind. And we're going to use HWY, which is the highway mileage of the car. And so we're going to ask the question, do cars with larger engines use more fuel than cars with smaller engines? And so you can probably already guess what the answer to this question is going to be. But let's make this more precise. Is this a linear or a non-linear trend? Are there any outliers we have to be aware of? And to answer this, the easiest way is to create a plot of the data. And so here is the code for creating such a plot. We're not going to get into exactly what it means just yet. We'll do that on the next slide. For now, I'm just going to take this and run it in the console, prove to you that it does in fact work. So type this in here, just copy that across, press enter, and we get an output here in this plot window. And so if, say, you are on files, you might have to click over to plots just to see that. And so that was pretty simple, 2 lines of code there. We'll explain what they mean in a second. Actually, you can almost kind of read it. So, the x-axis is engine size, the y-axis is highway mileage, and we get this lovely plot here. So all these grid lines sorted for us, all of these dots in place, really quite simple. It looks really good. Okay, let's break down exactly what we wrote there and why we did that. Okay, so we start by calling this ggplot function. And what this is going to do is going to create a base ggplot. Actually, I'm going to run this by itself, just so we can see what this looks like. So if I do ggplot and mpg, it's just going to create a grey window. Think of this as like the base plotting layer. As I mentioned before, ggplot is based on this grammar of graphics, this way of layering different layers to create a visualization. And so we start with using ggplot to create a base layer, and inside of this, inside the brackets, we specify what data set we want to be using for creating this plot. So here, create a ggplot using the mpg dataset. Currently, there's nothing displayed because we haven't told it to draw out anything, just create a base layer. And so we follow this by a plus. And a plus means add a new layer. And the next layer is going to be a point geometry. So we put a tab here, and this is just a convention. We could put this on one line, we could put it on, without an indent here, because R doesn't care about new lines or spaces. But to make it easier to read, we tend to put a new line after a plus and have a tab so it's indented past the initial ggplot. And so we're adding a point geometry. So a geometry is any kind of physical element of the plot. So it could be a point, could be a line, could be a box plot or a bar. All those things are called geometries. And so there are many geometries we have access to in the tidyverse in ggplot. If I type geom underscore, I can actually see them all listed here. I can use up and down, navigate between them. There's like a crazy number of things that we can plot. Probably plot types you've never even heard of before. And so in this case, we can use geom point to create a point geometry, so dots. And so inside of this, we have to specify what variables we want to use for different elements of our plots. And so these different kind of visual elements of the plot are known as aesthetics. So how can we describe a point? Well, we can describe it by its x position, its y position, its color, its size, how transparent it is. Those are all kind of aesthetic properties of a point. And so we refer to those as the aesthetics of that geometry. And so what we have to do to create a point geometry is to map variables in our data set to aesthetics of that point. And we do that inside of geom point, so inside of these brackets, by using this command, this function called AES, which is short for aesthetic. And so inside of here, we put our aesthetic mappings. So another set of brackets, and then we say, I want the x aesthetic to be equal to the column display, the engine size. Basically, take the engine size and use that for the x position of each point. And similarly, separate by a comma, so each of these inputs separated by a comma, we're going to set the y aesthetic, so the y position of each point, to be the highway mileage. And that's our full code here. So if we go back to the plot, I'm just going to go up to bring that back. So yeah, so the shortcut I was using there, you can go up and down with the up and down arrow in the console to go forward and backwards lines. We run this again, so base layer here just creates the grey area, and then add a point geometry, and the aesthetic mapping, so what variables map to the physical aesthetics of our points. Engine size maps to x, it's on the x-axis there, and the highway mileage maps to y. And so that gave us this simple plot here, with only 2 lines of code, fairly simple to do. Okay, and so the general template is something like this. So we run ggplot to create a base layer. and then put the data set we want to use inside of the brackets. And then we add a new layer. This is going to be a geometry. So geom underscore something. Could be point, could be line. We'll get onto some more geometries in later sessions. Now we'll stick with points. And then inside of that, we put AES to control our aesthetic mappings. And then inside of those brackets, we put our mappings. That's going to be some aesthetic is equal to some variable in our data set. And we can have as many as we want here, all of them separated by commas. It's worth mentioning at this point that R is case sensitive. And so if I say do ggplot with a capital G, it's not going to recognize that. It's going to say, it's going to give you an error saying I don't recognize that command. So it has to be ggplot, all lowercase, and the same for everything else here. And as I mentioned before, R does not care about indentation, new lines, or spaces. So if I take the code we had before, and if I put loads of spaces here, throw some spaces in there, perhaps add several new lines here, a new line in there, no one would want to read this code. It's very, very ugly. But if we run it, R understands it exactly the same, and we'll just create that plot we had before. We just had those conventions of a new line and a tab to make it easier for a human to read. Okay, and so another thing we might want to do is say to create a plot of highway mileage against city mileage, and it's CTY is the column in the data set. So we have a look at the data set again, just as a reminder, MPG. There's a column here, CTY, which is the city mileage. Let's create a plot of highway mileage against city mileage. So I'm going to create a ggplot. That is the base layer, and we're using the MPG dataset. Let's add a new layer. I'm going to put a tab in just to have it formatted the conventional way. We're going to add a geometry. That's going to be a point geometry. And you'll see here, I'm using the tab key to auto-complete things. When we start typing in R, or in RStudio to be exact, this is a feature of RStudio, one of those helpful features that make it easier to work, is it's going to give us suggestions of what we want to type in. So we typed in geom underscore PO. Now it's going to give us all the things that start with that. We'll actually match it closely. And then once we have the one we want by pressing up and down, you can press tab to autocomplete. That's just a handy feature there. And inside of that, we want our aesthetic mapping. So mapping variables to the aesthetic elements of the point. I'm going to have my X being city mileage and my Y being highway mileage. And so if I run that, I get a plot like this, fairly linear, as you would expect, with highway mileage being slightly higher than city mileage. Okay, so let's just take a moment to have a look at how we can work with data frames. So this thing, MPG, is a data frame. And that's kind of the R terminology for a data set. And so let's understand how we can kind of look into the details of this and kind of learn a bit more about what our data looks like. So we're going to run through a few useful commands here that you can use for kind of interrogating and understanding what your data looks like. Okay, so we can print the entirety of a data set using its name. So just type its name in the console, press enter, and that will print it out. Let's say we only want the first few rows, but then we can use a command called head. So think, the head is at the top of your body, give me the top of the data set. And so if we use head MPG, that's going to give us the first 6 rows by default of the data set. If you want a specific number of rows, we can add an extra input to this command, separated by a comma. And that's going to be a named input called n. So give me the first few rows of the Malbergal dataset, in comma to separate the inputs, and the number I want, the n, is equal to 3. So if I have n equals 3, it's going to give me the first 3 rows of that dataset. And a similar command is tail. So if head gives you the first rows, and tail should give you the bottom rows. So for example, I could do tail mpg n equals 2. And that's going to give me the bottom 2 rows of the data set. We can tell that because we have Volkswagen, they're in alphabetical order. Okay, so how can we get kind of overviews of what our data set looks like? Well, one method is using this str command, and that is short for structure. It gives us the structure of our data set, the column names, the data types, and the first few values. If I ask for the structure, the str of MPG of that data set, I get something like this. So all of the column names and the data types. So this is character, it's text data, numerical data, integer, so whole number data, and there are a few other types in R that aren't included in this data set. Okay, and another thing we can do, a bit more powerful, is the summary function. And that gives us statistical summaries of each column in our data set. So if I take that, I can use summary, run MPG. That's going to give me numeric summaries of all the columns. So for text columns, it just counts how many there are. But for something numeric like the engine size, it gives me the minimum, maximum, the 3 interior quartiles, and the mean of that column. So it's a very useful way of getting a quick summary of what our data looks like. And you could maybe spot an outlier from this if, say, the maximum was something like 500 here, you know something's gone wrong. And finally, how can we access a specific column of our data set? There's two methods for this, the $ and the double square brackets. And so the most common one is the $. If I have my MPG data set and followed that by a $, RStudio is now going to try and complete what I want here. And let's say I want to print out the year column. So I can either click it or use the up and down arrows, then press tab to complete, and run that there. So this is saying take the Malpagal data set, the $ accesses columns, and the column we want is the year column. And that prints it out here. So we can see that they're all 1999 or 2008. So the $ works fine in most cases. It's going to break when our column name has a space in it. It's not clear whether, I guess if we had, MPG col with space, it's not clear whether the command I'm running is take the Malpagal column called col and then do something called with space, or the column is called col with space. And so we're not allowed to use the $ whenever we have a column name that has a space in it. Instead, we use double square brackets and put some text data, which we denote by either single or double quotes. They mean the same in R. And then close the double square brackets. So take the Malpagal data set and then extract the column col with space. Now, if I run this, I'm going to get a null because that column doesn't exist. But if there was a column in this data set with spaces, that's the way I would access that. But generally, we tend to use the first one. It's just more elegant. Okay, so we've seen so far how to create a simple plot. But now let's make them a bit more interesting by adding, say, colors and various other aesthetics to our point geometries. Okay, so looking at the plot we had before, let's have a quick look at it here. If I go back in the plotting window, I can see that. There's generally this kind of maybe linear, maybe non-linear trend, and then a few outliers here. These seem to have a lot larger highway mileage than they reasonably should, or maybe their engine size is bigger than they should for their highway mileage. The causality is hard to tell. So we might want to explain what's going on there. Why are those outliers? How can we summarize kind of what cars they are? And so we can do this by adding another variable to the plot to help explain things with an extra dimension. And so this is the beauty of ggplot, that adding a new thing like this is as simple as it was adding X and Y aesthetics. We just do the same thing again, but now for a color aesthetic. And so we can use the template we had before, just with one extra thing added. And so a sensible thing to do might be to take the type of car. So if we have a look at the MPG dataset, if I can spell it correctly, we'll see the last column is this thing called class. If I look at the column itself with the $, we see that it has the type of car, so SUV, subcompact, pickup, various things like that. And we might want to colour the points by what type of car they are. That might help us detect the pattern. And so we can do this by taking this class column and mapping it to the colour aesthetic. It's very simple. So to do that, we'd have something like this. So we have the code we had before. Start with a base layer, so create a ggplot using the Malpighian dataset, create a point geometry, and then we had those two aesthetics from before. So X is engine size, dispel, Y is the highway mileage. Then we just add a comma and say our colour is the class. So whereas with maybe Python, you'd have to kind of use a different method for adding the colour than you would for the X and Y coordinates. It can be an absolute pain. Here, it's really consistent. And for adding anything else, the size of points, the transparency, the shape of points, it's this exact same method. And so hopefully you're starting to see, even though this method might seem a bit strange, this layering, there's a reason for it. It makes it really easy to expand things in a flexible way. And so, let's take this. Actually, no, we'll edit the one we had before, make it clear. So I'm pressing up here to go back to the old code. So there we go, we had code like this. So let's add on colour equals to class. I run this and I get a plot like this. And we can instantly see, oh, okay, these outlier cars are the two-seaters, the sports cars. These have very big engines, but they're still fairly light, so their highway mileage is pretty decent. And that's why those are the outliers there. Okay, so we're not limited to just adding colours to our plots. We can also control the size of our points. And we do that using the size aesthetic. The transparency, we can use alpha for that, or the shape of the points. So then we'll talk about that more in a second. And so depending on the type of our data, whether it's continuous, so taking any value, discrete, taking a fixed number of values, sorry, not a fixed number of values, but things like integers, where they have to be whole numbers, or categorical, where there's a fixed finite number of things, different mappings, different aesthetics will be more appropriate. So mapping a continuous variable to colour makes sense. We can have a spectrum. Mapping a continuous thing to shape doesn't make any sense and will probably get an error. Now, sometimes a categorical variable can be stored in a dataset as a discrete or continuous variable, and that's a problem. And so in this case, we have to explicitly tell ggplot that we're wanting to treat it as a categorical variable, so one with a fixed number of levels, by using a function called factor. And if you're mathematical, you can think of this as kind of factorizing the variable. Do we have an example of this? No, let's have a look at an example of that then. So to do this, okay, so let's have a plot, and let's have the one we had before. So let's start with something like, so we'll have a ggplot, and we're going to add a point geometry. Let's first show off some of the other aesthetics. Let's have X is highway mileage, Y is city mileage, and size is going to be the engine size. I run that and I get this plot here. So really simple. Set that to size. ggplot figured out kind of what legend to use, how to scale these correctly. Really easy, just like one extra bit of code here, and we instantly get a nice plot. Now what I'm going to do, I'm going to colour the points, so colour by the year. And we're going to see that this is going to go wrong here. If I run this, we get something like this. And on the plot itself, it looks okay, but this is kind of strange here. Because if we remember, looking at the Malpighian dataset, the year only takes two values, 1999 and 2008. So really here, we would want a legend that only has two values on it. We've ended up with one that has a whole spectrum. And that's because ggplot didn't know that this was categorical, didn't know there was only two levels. It could have been the case that any year is allowed, we just so happen to only have two of them. But we know from kind of knowing the dataset itself, actually these are the only two levels, and we'd rather have a two-level legend here. And so to do that, we have to explicitly tell ggplot, no, this is categorical. And we do that using the factor function. We take our year, and we put that inside of factor. So this is saying, no, this is definitely a categorical variable. So take year and then factor that to make it categorical. And if I run this now, we now get two levels in our legends and colors that are further apart. Rather than two shades of blue, it's a blue and a red. You can see here that some of the ones with the highest mileage were these old cars. I think these are the old Volkswagens. And so this is a much better way of looking at things. We will practice that more in the homework to kind of get used to that. And we saw there that whenever we have an aesthetic mapping, ggplot will automatically scale the variable, will add a legend. It's really quite a convenient way of doing things and does a lot for us. Okay, so we saw there how to take a variable and map that to an aesthetic. Let's say rather than doing that, we want to manually set an aesthetic for the whole plot, to make all points orange regardless of what data the observation contains. And so we can do that by doing an aesthetic mapping outside of the AES function. So the AES function is used for mapping variables to an aesthetic. If we're manually setting something, then we should run that outside of AES. Here's an example. We want to set all of our points to be orange. So we do ggplot mile per gallon, same as before. Our geom point, then our aesthetic only contains x and y. Then we close the aesthetic bracket, put a comma to separate our inputs to geom point, and then set our color to be the text orange. And we need to use quotes here just to let R know that this is kind of text data we're giving it, the text orange. If we run that, we get something like the plot shown below. I'll show you that in RStudio as well. That looks good. So what would happen if we'd have put this inside of the aesthetic mapping? So you might think it's going to give us an error. Actually, it's going to do something. It's going to try and do something, just something a bit strange. We're going to get this plot here. This is kind of the general philosophy of R and the Tidyverse, is that whenever you give it something strange, it will give it a shot. And so other languages like Java and C will fail very eagerly. If things aren't exactly right, then they'll fail and say, no, this isn't allowed. Whereas R will give it a shot. It might give you a weird output, but it'll give it a go. This can be good because you can get some kind of very flexible functionality. It can be bad because it will let you make mistakes without explicitly telling you something's gone wrong. So what happened here? So we ended up with points that were red, not orange, and we now have a legend that has the value orange on it. So what's happened here? So if we have a look at MPG, we'll see that there is no column called orange. But what's happened here? We put color equals orange inside of an aesthetic mapping. So ggplot understands this as you want to map something, want to map a variable to the color. We haven't actually specified a variable here, we're just given a value. And so what ggplot's going to do is going to go, oh, well, you're probably talking about a column that doesn't exist yet. What I'm going to do, I'm going to create a column for you. And so it temporarily adds an extra column to the dataset where every single value is orange. And so it creates that column for us, and then it's going to map that column to the color aesthetic. I guess this makes sense. We've told it to map a variable to the color. We've done it inside of AES. And so it's just going to do that. But the problem now occurs that for a start, we get a legend, and the only value in the legend is orange because this new column it's created only has the value orange. And also, when we're creating aesthetic mappings to color that are categorical, let's say if I use class here, the colors used kind of start with red, then they go red and blue, then red, blue and green, red, blue, green, purple, and then they become the rainbow here. And so when we only have a single level in our categorical variable, it's going to give us red points. And so, when we added this imaginary column orange, we only had one level to it, and so ggplot used the default red for that. And so if you get a weird output like that, it's probably you wanted this outside of the aesthetic. So just be aware of that And we'll learn more about that in the homework. Okay, so more about manually setting aesthetics. It's important that when we specify a value for an aesthetic, that it makes sense. So if we're setting the value of a color aesthetic, we can either use a character string, so the name of a color inside of single or double quotes. I'll re-emphasize single and double quotes mean the same thing in R. Or we can use a color code. So if you're familiar with Photoshop, you'll recognize these 6-digit hexadecimal codes. And so you could put like some quotes, hashtag, and then these codes here. If we're mapping something to the size of a point, then we can use a number. That's going to be the size of the points in millimeters. If we're mapping to the shape of a point, then we can use an integer. That's going to choose something from this table across here. So we could use 17 for a solid triangle, 2 for a hollow triangle. Or we can use a single character. So say we used the character in quotes P, all of our data points will be the letter P. Let's actually just see a quick example of that. Let's take the plot here. And this is a manual one to do it outside of AES. And we're going to say the shape is going to be, well, let's start with 2. That's going to give us these hollow triangles. We'll do it again with the shape. Let's use the @ symbol. And so now we have @ symbols for all of the data. Don't know why you want to do that, but I mean, hell, that's the flexibility of ggplot. Why not? Okay, so let's now have a look at coloring. So in this in these shapes over here, there are 3 different types. So there's the hollow ones, that's 0 to 14. There is the solid ones, so 15 to 20. And then the filled ones are 21, weird order there, 21 to 24. So the hollow ones and the solid ones can have their color controlled using the color aesthetic. But these filled ones at the end here, these take 2 different aesthetics. There is fill for specifying the interior color, and then color for specifying the exterior outline. So for these first ones, it's just color for their single color. These ones, it's fill and color. Because we take this one here, we'll use a shape of 24. We're going to set the fill to be red and the color to be blue. So then we get these fill shapes, red on the inside, blue on the outside. Very ugly, but if you want to do that, then we can. Okay, the last thing we're going to look at is these things called facets. And that's a way of taking our plot and breaking it up into multiple subplots for different subsets of our data. Okay, so we've seen a lot of aesthetics, and they offer a lot of flexibility in how we can represent our data. But the problem is as we add more and more aesthetics, it becomes harder and harder to interpret our data. Like we have a plot that has x, y coordinates, color, size, transparency, and shape, all controlling different variables. It's going to be really hard to understand what's going on and pull out patterns in the plot. So another way, particularly when we're trying to understand how categorical variables vary in our data set, is to split the plot into these things called facets. Basically, take our big plot and break it up into smaller subplots, one for each subset of the data. And there's 2 ways of doing this, using facet wrap and facet grid. Okay, we'll have a look at facet wrap first. And this allows us to facet our plot by a single variable. And so the first argument of facet should be a formula. And so the notation for a formula is a tilde. It's kind of squiggle sign here. On my keyboard, it's on the right above the hashtag. Might be a different position for yours. And then we follow that by whatever variable we want to facet by. And the way you would read, say, tilde class is facet by the class. And so the variable we're faceting by should be discrete or categorical, so only a fixed number of levels. And we can also control the layout of these facets using nrow and ncol for the number of rows and the number of columns. So an example of that is shown here. So we take our normal plot, so plot of mile per gallon with our point aesthetic. Actually, let's do this live to make it clear. That's our normal plot. We can see that at the bottom. And now we're going to add another layer, so a faceting layer. And again, this is the philosophy of ggplot, adding layers one by one. We're going to have a tab just to indent that. And we're going to use facet wrap. I want to wrap by the class variable. And the number of rows I want is going to be, so n row is equal to 2. I run this and I get this plot here showing these 7 different classes in 2 rows. So, I mean, again, added one line here and suddenly we have a really kind of advanced plot here split out. Like, can you do that in Excel? I'm not sure. Like, you might have to make 7 different plots for that. Whereas here, just a single line. It's really quite elegant. We could also use ncol to specify how many columns we wanted. Or if we use neither nrow or ncol, ggplot will just make a guess for us at what looks best. Okay, and so we may also want to color the points in our different facets. If I take the plot above, I want to color by the class as well, and then add my my facet. I get something like this, so it looks good. The problem with this is that we have an unnecessary legend. We don't need the legend because the title of each facet tells us what the color is. And so what we can do, when we use geoInPoint, we can add outside the aesthetic mapping, show.legend equals, then in all caps, false. If we try to type false without the all caps, it won't turn a color, and it'll suggest, I press tab here, to convert to actually false. And so when we, made a mistake there. There we go. When we use show legend equals false, it's going to get rid of the legend and make it focus on the actual plot itself. And so the code for that is here. Okay, and so the final thing we're going to look at is facet grid. And this allows us to facet with a combination of 2 variables. So facet wrap takes a single variable, whereas facet grid takes 2. It's also in the form of a formula. This time we put variables on the left and right hand side of the formula. The first one will facet by the rows and the second by the columns. So an example of this is we'll have the standard point plot we had before, add a new layer. This layer is going to be a facet grid layer. And then rather than just having tilde variable, we have variable tilde variable. So facet the rows by the drive type, whether it's 4-wheel drive, front or rear. And then the columns by the number of cylinders, 4, 5, 6, or 8. And so this gives us a bit more control over controlling 2 different variables. And if we want to only facet in one direction, then we can replace one of the variables, the row or the column one, with a dot. And that means don't facet in that direction. So here we don't facet the rows, we facet the columns by the cylinder, the number of cylinders. Okay, so obviously that was a lot of material in today's session. It's more than there's going to be in a normal session, just because I want to leave you with enough to be able to actually go and do something interesting. It would be a shame to have the first session and feel like you can't do anything with it. Like, you now should have enough to actually make some cool visualizations and kind of show those off. But yeah, the point of the course is to be fast, is to be very brief. You do not need to remember anything that was taught in this session. Just remember what you can do and whereabouts in the presentation you can find it. The presentation's up on the course website. You can always come back to it and use it as a reference guide. And in the homeworks, that's when you actually learn how to apply this stuff and get some practice with it. So in terms of getting help, a few points. Yeah, this course is learned by doing, not by watching. So you're going to make mistakes. That's all right. You're going to not know what to do. You're going to be a bit confused at times. That's all right. That's part of the learning experience. It's going to take some time for you to commit these things to memory. That's okay. Just have the presentation open while you're doing the homeworks and kind of transfer those across and learn while doing that. And you can always come back to the slides. So I'm contactable on LinkedIn if you need me, but generally I'm not going to be too responsive. Your main port of call if you're taking this internally in the society is your mentor. If there's any issues they can't solve, they can raise it to the course coordinator. But if you're watching externally or you really need my attention, you can find me on LinkedIn. And so feel free to work with other people taking the course and ask a lot of questions to your mentors. They're there for a reason, and make sure you take advantage of that. In terms of online resources, there's a website called Stack Overflow. It's a great resource for learning how to code. Pretty much every beginning question has been asked on there. So I would avoid asking questions, but rather search for ones that exist already to avoid duplication. There's a great community for R and the Tidyverse on the web. If you search your problem followed by R, Tidyverse, or whatever package you're using, say ggplot 2, you'll probably get a helpful guide or solution for whatever you're trying to do. And the Tidyverse has a website linked here. Great tutorials, great help guides, documentation. Have a look at that. And there's also cheat sheets, which are kind of these very dense documents on how you can do everything for each of the packages in the Tidyverse. So check those out from the link in the presentation if you're interested. Finally, getting help from within R, we can use this question mark symbol. And that's going to give us help on whatever we follow it with. So if I do question mark MPG, it's going to open a help file about the MPG dataset. Gives us a description, gives us definitions of the columns, kind of very useful, helpful features like that. I can also use a question mark for a function, for a command. I just don't put the brackets on the end. So if I do facet wrap without the brackets, that's going to give me a help guide for facet wrap. Explain how to use it, and most importantly at the bottom, give some examples. They're really useful here. You can take this, copy that across, run it, and that's going to give you output there. What I did there, that won't make sense till second session, so don't worry about that for now. We'll explain that next time. So with that, we'll end the session there. Hopefully, you've enjoyed learning how to plot stuff and are going to have a lot of fun applying it for yourself in the homework session. So see you next time.